Hi, and welcome to the latest in our Minecraft Education Edition curriculum webinar series. My name is Simon. I'm a former ICT and computing teacher with several years experience in education. I'm an MIE expert and also a Minecraft Global Mentor. And in this session, we're going to explore how you can use Minecraft to teach aspects of computing. So we'll discover how Minecraft can be used to teach elements of the computing curriculum, learn how to code in Minecraft with some basic tutorials, and explore how to use Minecraft to help students transition from block-based programming languages, similar to Scratch, to text-based languages. So let's jump right in. Here is a list of requirements for teaching computing in England. And this is not an exhaustive list, but it is a few that we can cover using Minecraft. So at Key Stage 2, children are expected to design, write and debug programs, use sequence, selection and repetition in programs, and also use logical reasoning to explain how simple algorithms work and detect and correct errors. And then when children start Key Stage 3, they're expected to be able to model the behavior of real-world problems, understand several key algorithms, use 2 or more programming languages, of which at least one is textual, and also be able to understand simple Boolean logic. So in Minecraft Education Edition, children can code using blocks similar to Scratch. They can also use JavaScript and Python. They can also program a robot called the agent. So this is similar to those floor robots like Bebot and Roma, but programmable in Minecraft. I thought I'd start with a simple tutorial and then follow that up with some vocabulary that's going to be useful throughout this session. As any computing teacher will start with, I'm going to start with the classic hello world. Now I'm going to launch Minecraft. I'm going to click on play, and I'm going to, instead of starting a new world, I'm going to click on create new, and I'm going to choose templates. And I'm going to select blocks of grass and then click on play. Now, the reason why I've chose this one is that if you create a normal world, it'll generate trees and forests and hills and rivers and ravines. This can be very distracting, especially if you're programming your floor robot. So I find that especially when starting to learn to code in Minecraft the first time, that you start with a blank canvas, and the blocks of grass templates gives us this. So to start coding, we press the letter C on the keyboard, and this will bring up our code builder. You'll notice that we have a selection of tutorials and also some boilerplate code or templates. So here are tutorials of chicken rain and flower trail. And then we've got some examples that the children can explore and tinker with later. And I'll explain in more detail how we can use these a little later on. I'm going to start by creating a new program. I'm going to call this Hello World and click on create. So on the side here, you can see our blocks. We've got our basic blocks. These are the most common used commands. So we can use a trigger word to start our code, place blocks, spawn animals. I'll talk about animals and mobs a little later. You've also got loops, so you can introduce iteration. We've got repeat, while, and for. We can also click on logic, so we can explore selection as well, and conditions. So we've got our if statements. But I'm going to start with the blocks. I'm going to find the block called print hello. There it is. I'm going to click and drag that. I'm going to place it on my start command. I'm going to change the text to hello world. And the children can choose their blocks. I'm going to do what the children do and pick TNT. And the only other thing we're going to change is our coordinates. So these coordinates are here are relative to your position. And the one that I want to concentrate on for this example is this middle one here. And this is your height block. And the height is in number of blocks. So I'm going to say I want to type my message 10 blocks above my head. So the code is saying when I press the start button, print the word hello world in TNT 10 blocks above my head. So let's go ahead. I press run and I look up and step back, and hopefully somewhere there it is. I can see my message slowly printing. And don't worry, this isn't how slow it'll print on your computer. It's just because I'm running Teams and Minecraft and PowerPoint all at the same time. My computer doesn't like it. The sheep seem to like it. And it's as simple as that. So I mentioned that I'll also use this opportunity to explore some of the vocabulary that's going to be useful, especially later on when we look at some of the other tutorials. So Minecraft is, if you've never played Minecraft before, it's a sandbox game. Best analogy I can use for that is that imagine you've got a giant sand pit and your raw materials are grains of sand. Using that sand and some water, you can create a sand turret, sand castle, or you can create a sand model of Hogwarts. The only limit is imagination. So in Minecraft, your blocks or your raw materials are blocks, and each block is 1 meter cubed. So I mentioned in previous webinars, especially when we're exploring curriculum, that this lends itself well to maths because you can explore volume and area of different shapes. Now, each block has different settings and different attributes. So one of those attributes is the item ID. So this will say what type of block it is. So we'll have a dirt block, wall, and clay. And for some of these blocks, in particular the wall blocks and the clay blocks that have different colors, you will have item data. So this will represent, in this case, the color. So 14 is red wool. In Minecraft, you have 2 main players, Steve and Alex. I mentioned in previous webinars, you can also change the skins. So there's lots of education skins. So you can be a Viking or you can be an astronaut. So you can choose that to support your creative writing or to fit in with whatever era or topic that you're using in Minecraft. In code, you can tag or identify these different players using the @ command. So @A will select all the players in the game. @C will select your agent. So that's that little floor robot. P is closest player and S is yourself. You can also identify individuals by their name as well. Time in Minecraft is measured in ticks. So these aren't those nasty things that suck your blood. A day in Minecraft lasts approximately about 20 minutes, which is equivalent to 24,000 ticks. And you can manually change that in Minecraft using code or commands, so you can make it instantly night or instantly day. And then I mentioned earlier when I was looking at Hello World, we looked at spawning mobs. So mob is short for mobile, and these are the other entities in the game that the players can interact with that are not other players. So things like chickens and polar bears and panda bears and cows. You also have hostile mobs too. So these are mobs that can cause harm and damage. The most famous or infamous one being the creeper. And you also have your coordinates. So the coordinates are measured in X, Y, and Z, where Z is your forward and backwards coordinates, Y is your height coordinates, and Z refers to the left and to the right of you relative to your position. And this is ideal for creating pixel art. And there are some pixel art tutorials you can find on the Microsoft website. So let's have a go at creating something a little bit more complex. So in this next tutorial, I'm going to make it rain chickens. So I'm going to go back to Minecraft and I'm going to resume my world. Notice we've got a bit of an audience now looking at my wonderful code. I'm going to just move it away. I'm going to press the letter C again to bring up my code connections, and I'm going to click on Home. And I'm going to create a new project. I'm going to call this Chicken Rain. And click on Create. And this time, instead of running the code when I press the play button, I'm going to use a command. Now, the nice thing about commands is that if you press the play button, the code will run straight away, and it might be running above your head. You need to kind of move it away or reposition yourself to see the code run. You might be not quick enough to catch it. So you can put in a little command so you can get your character set in the correct position before launching your code. So we're going to say on the chat command chicken, we're going to run our code. So when a student types in chicken in their chat window in Minecraft, it will launch our code. And we're going to spawn our character. So we're going to go to our mobs. So this is our mobile character, the entities. And we're going to use the spawn animal. Now, by default, the animal is chicken, but you can choose other ones. We've got pigs and cows and sheep. And we're going to use the height block again, so that's the middle one, and we're going to change that to about 10 again, so it's going to spawn the chicken 10 blocks above my head. So I press run to start, and then I compose myself and get my character in position, and I then press T to bring up the chat, and I'm going to type in the word chicken to launch my code. If I look in the air, there's my chicken, although it's not exactly raining chickens. Oh, I love chicken. So I'm going to go back, press letter C to bring up my code. And now I'm going to add some iterations, and I'm going to go to my loops. Now the children will be inclined to click on the forever loop. I highly recommend you don't do this, otherwise it'll probably crash your system. But I'm going to be using the repeat loop command, and I'm going to drag my spawn inside that, and let's have 100 chicken. That's quite sensible. So it's now going to say when I run the chicken command 100 times, it will spawn a chicken 10 blocks above my head. So let's press run, and you're now going to have some friends, little chicken. So press letter T to bring up the chat, and then type in chicken. I can either press enter or I can press the go button, and now it is raining chickens. And it's as simple as that. So how do you get started coding in Minecraft? Because it might be that you think, oh, this is a great idea. I love this. I'm going to go my lesson next week. I'm going to get the children making it rain chickens, but I forgot what the code is. So built into Minecraft are a series of tutorials and lessons all around computing. So if I launch Minecraft, and I'm going to save and exit, I'm going to go back to my main menu. There is a complete lesson library. So there are, under View Library, we have our subject kits. So we have science, we have maths, equity and inclusion, social and emotional, or social and emotion, as the kids would say these days. And we've also got some esports. And we also have a section on computer science. So we have our hour of code tutorials, tutorials for using the blocks in Minecraft, Python. Then we have a number to support transition from blocks to Python to JavaScript. We've even got some lessons on AI, which explore aspects such as computer vision, and we've also got some featured lessons as well. So if I were to click on block-based coding, here we've got some tutorials I can follow and some lessons. Incidentally, any lesson in Minecraft you can now share via Teams or Google Classrooms. If I were to, for example, click on computing with Minecraft, and I'm going to find a lesson. Let's do computing unit 2. I can then click on assign or share, and I can share that as an assignment in Teams. So if I click on that, it will load Teams and create an assignment. I can share it via Google Classroom or as an email. I can even share a link with the students, and I can also, and this is really useful, add a resource. So anything that can have a URL or web address attached to it or assigned to it, you can share. So it could be a shared OneNote, it could be a PowerPoint presentation with your learning objectives or learning outcomes or some instructions, or it could be a link to a video tutorial. I can then type in the URL. So I'm just going to put here http:/education.minecraft.net. But I said that this could be anything that has a URL associated with it, and then give the button a name. And then when I share that with the students, they can then just click on the link. It will automatically launch Minecraft and it will load that world. So it cuts out all those steps. They don't have to click on play, library, and find the world. Just click on the link, it'll launch Minecraft, sign them in, and open the world, and it will attach that link to those resources as well. You also have tutorials built into the coding environment in Minecraft. So if I go back to Minecraft and I go back to my main menu and click on create new and templates and create another blocks of grass. You've also got tutorials built into the coding environment, and you've got tutorials for blocks, for Python, and for JavaScript too. Now I'm going to demonstrate a blocks tutorial, but everything works the same for the other tutorials as well. So remember, you press letter C to bring up the code builder. And if I scroll down below my projects, we've got tutorials. So there's the rain chicken tutorial. So if you've forgotten how to make it rain chickens, not a problem. You can have the children do this in their own pace, in their own time. So click on chicken rain. You've got blocks, Python and JavaScript. I'm going to choose blocks. And then you'll get an instruction. You get a GIF or GIF showing you what the code should look like when it's working. And then click OK. And so it says put in an on chat command. There's one there already, and rename it to chicken. Now, if I'm not sure what that means, at any point I can click on the help button and it'll show me what it should look like. So, okay, I've got it now. So I'll type in the word chicken in here and go to the next step. Now, I know some people don't like tutorials. They're great for everyone to be at the same stage and the same level and working at the same pace. But I often find that children forget the code after they complete the tutorial. I will explore shortly after I've demonstrated this some strategies around using tutorials and why they're so useful. But at the moment, we're just going to follow this tutorial. So next is putting a spawn block. So I'm guessing because that's purple, spawn's going into mobs. But if I'm not sure, I can again click to see what it looks like. Okay, so mobs and spawn animal. And next, it says, right, the second number, let's even give an example this time, is 10, so change that to 10. Okay, so change that to 10, like so. And then it says, okay, go to Minecraft, press T, and enter the word chicken in the chat. Chicken in the chat, that's my new catchphrase. So run the code. I do need to get it more. Press letter T and type in chicken in the chat and run. And there's my chicken. It's as simple as that. Hello, little chicken. So those are the tutorials. We're in Minecraft. And also we have area of code tutorials. So these are, again, step-by-step tutorials that children can follow. But with the area of code ones, there is a story and a mission. So this is the AI area of code tutorial.
Forests help ensure clean air, fresh water, and sustain life for more than half the world's species. But many forests are threatened by climate change, loss of biodiversity, land degradation, and fires. The AI for Earth team at Microsoft uses artificial intelligence, or AI, to collect and analyze data about our planet to better protect it. For the Minecraft Hour of Code, we're going to protect a village and save a forest with the power of code. And learn about AI along the way. Okay, let's get started. First, make sure you download the Minecraft Education Edition app. If you are licensed for Minecraft Education Edition and have an Office 365 for Education account, sign in and navigate to the Hour of Code lesson in the library. If you don't have an account yet, that's okay. Go ahead and click Start Lesson. You'll land right in the 3D Minecraft world. And this is where the fun begins. Start by learning to move using the keyboard and mouse or touch commands. When you see an NPC or non-player character, as well, right-click to read what they have to say. This starts the tutorial. Help you read them in other languages. Come from the book on the first reader here. You'll then follow the path through 8 different tests that will teach you the basics of coding while using AI to help prevent forest fires. Happy coding!
So what I love about that tutorial is, one, it teaches children to code. 2, it provides a context. So context is key to learning. And in this case, it introduces the idea of programming these small robots that can go into the field and search for combustible items, so items that could accelerate a fire. So it could be dead foliage or discarded glass bottles, and it will remove those. Now, it's not going to stop wildfires in the future, but by removing those combustible items, it can prevent or reduce the damage caused by those wildfires using AI and computer vision. So why use Minecraft and games in particular to teach computing and teach children to learn to code? So I find that Minecraft can give children a meaningful and real context. So we just saw an example with the AI code, using code and using AI to help solve a problem that children may be aware of or might care about. Also as well, I remember years ago when I started to teach ICT, we had a project for GCSE where the children had to build a DVD booking system. And the kids enjoyed searching for their favourite films, but the children would turn around to me and say, "Sir, why would you go to a shop and hire a film?" And I thought, don't even get me started on tapes and having to rewind tapes and VHS. But it's because it had no meaning for them. They're used to downloading films or streaming them live on streaming platforms. So it wasn't relevant to them. So Minecraft, being a game that they're familiar with, is, and you might say to a child, well, okay, how long would it take you to build a house in Minecraft? They say, oh, it might take me 10, 20 minutes. So how about if you wanted to build a whole city on your own? So, oh, it might take hours or days. I said, well, what if you could build that in code in 10 minutes? Or in Minecraft, because it's an open world, because it's a sandbox, you can easily get lost. And I say to how many children here have built a world in Minecraft, built a house, and then gone off wandering and lost your house. You spent hours building this wonderful home and you can't find it because you're lost. What if you could use code to create a trail of flowers, just like the Hansel and Gretel, so you always be able to find your way back? And the kid's like, wow, wow. This provides a context. I also find as well that when children code something physical, in this case the agent, and also when we programming physical robots like the B-bot or Roma, they can see the immediate impact of the code, so they can immediately see if there's an error in their code. I also find that games in particular are great for helping children with resilience. The problem with the traditional classroom is that there's so much pressures on the teacher and so many pressures on the children to achieve and to meet their targets. There's no room for children to fail. And yet failure is a really powerful lesson, especially if you learn from those mistakes. The one thing I like about games and what children find in games is that they're used to failure. They're used to dying in Minecraft, being killed, blown up by a creeper, or being killed by the final boss. But they know that if that happens, they'll start again and they can try a new strategy. So games already give them this platform, this safe environment where they can fail and try again and try to improve. Although I'm going to be honest with you, Minecraft, especially when teaching the coding, is not without its challenges. And one of those challenges is the fact that previous and traditional experience of coding is using tools like Scratch. We have this 2D platform and a character, a cat, will move left or right, or up and down. Or in Python, you'll have some text that appears on the screen. So one of the first biggest challenges is coding in an immersive world. So in this 3D world, and also with coordinates. I often find this is an issue as well, especially with younger children and programming robots. They can program, it's almost like chess, they can probably program 10 moves ahead, but then they can't visualize in the head, okay, what's the next move? Is it left or right? Which way is the robot facing? And it's the same issue in Minecraft because they're immersed in this 3D world. The other challenge I find as well is that I assumed when I first started using Minecraft with my children is that they know Minecraft and they'll pick it up like a duck to water. The problem is their experience of Minecraft at home might be using the console edition, so using the controller, or using Pocket Edition. Now, if you have a device that's touchscreen, like a Microsoft Surface, then you can use the Pocket Edition controls. But if you haven't, the children find it difficult or confusing at first using the keyboard and mouse to control the characters in Minecraft. One strategy I've used and found that works before introducing children to coding in Minecraft is to have them explore the area of code tutorials. So if you go to code.org/Minecraft, you can access for free activities and challenges where you control characters like the agent or Steve or Alex and get them to complete mazes. Using blocks very similar to those in the game itself, but in a nice 2D environment that they're already familiar with. Once they've mastered the code in the 2D environment, then it's easier for them to pick up the coding when they're in the Minecraft 3D environment. I can't do a webinar about computing and coding without mentioning cognitive load. So if you're not familiar with the cognitive load theory, this cognitive load relates to the amount of information that a child can store in their working short-term memory. And what often happens, especially when introducing children to a new topic, particularly coding, is if you give them too many options or too much information, their brain gets overloaded, their short-term memory gets full, and they find it difficult to remember. So there's a number of strategies that we can use to try and reduce this cognitive load. I mean, there's a number of strategies we can use in Minecraft. The first one relates to tutorials. So if I go back to the tutorials, and if I load up Minecraft, and if I resume my game, and then press the letter C, and I'm going to, whilst in the tutorial, notice on the left-hand side, it only gives us the blocks that we need. So straight away, there's fewer options, and fewer options means less confusion. So if I go into the next code here, it got repeat, so it adds the loops, and if I click on the loops, it also removed the forever and the while loops and all the other ones, and so that students can only need to concentrate on the blocks that they need, like so. Another thing students can do is, or as a teacher to reduce cognitive load, is use an activity called Parsons problems. Now, Parsons problems, you might have used this before and hadn't realized it had a name. It's a type of scaffolding where you give the children a complete or partially completed solution, and you jumble the code up, and then the children have to put it back in the correct sequence. So I have an example here, and they're really easy to do. So if I go back to my main menu, just exit the tutorial, I have a project called Square. So this is the code to create a square using the almost like turtle. So those who've used the turtle library in Python or the pen library in Scratch, this is create a square out of blocks in Python, in Minecraft. So all the code blocks are there, but it's been broken up like a jigsaw puzzle, and the students have to put the blocks back in the correct order and fill in the missing gaps, and then run the code. So that's Parsons problems. You can also add some differentiation as well, make it more challenging by putting in blocks called distractors. So these are blocks that if you put them in the code, they're not going to break the code, but they have no real functionality, so they don't need to be there. I've heard another version of this, which is code Jenga, where you give them the completed solution and you put in lots of distractors, and the children have to take it in turns to pull out the distractors until the first person breaks the code. But one of my favorite strategies to support cognitive load is, and to reduce it, is use, modify, create, or PRIMM. I often start with use, modify, create, so the students get used to the idea, and then move on to using PRIMM. But the idea is that the children are given some code. They then have to kind of predict what the code is going to do, and then the teacher or the student runs the code to see if they were right. They then start to modify the code, investigate it to see what it does, change some of the variables, and then once they're finished, they can create something new based on that code. So I did mention earlier that I'm not a massive fan of tutorials, because I often find that the students forget, once the tutorial is complete, how to write the program again. But you can use the tutorials, and at the end of the tutorials, have the children then change the code and tinker the code, change some of the numbers, change some of the blocks to see what would happen, and then make something new based on that. Or you can use the boilerplate code or the templates. So down here we've got some examples. So for example, we have build a wall. So we can click on that and open that in blocks, open example. The children can then look at the code and try to guess what it's going to do. So it's called wall, and it seems to be placing lots of wall blocks. So you assume it's going to build a wall. So they run the code to see what happens. And then if they're correct, then they go back to the code. So in this case, it was on chat command, type in wall. And then they can start changing some of the blocks. So they can move the character 10 blocks instead of 5. They can move the builder up 2 blocks instead of 1. And they can also change the blocks. So have snow, for example. And then let's change that to 6. And then go back in the code, run it, and then type in wall in the chat. And then we have wall. So then the children can go back and they can start modifying that and tinker, and they even create their own code. So they might want to make, instead of a wall, they might want to make a building or a house based on this code. And then my final favorite example is worked examples. Now, teachers use worked examples in English, in maths all the time. And worked examples are great in computing. So a worked example is basically a scaffold, very similar to Parsons problems, but rather than being jumbled up, we give the children a partially completed code, and we then, or complete code, and then we take some elements out. So it could be we remove the number of iterations, or we miss out an important block, and then we used sub-goal labels. So these are comments in the code to give the student instructions on what to do. So if I go back to Minecraft and show you how easy it is to do. So as a teacher, I can load up, let's load up my square code. So now it's complete. So I can share this with my students, but before I share it, I can remove some items. So I can change that to 0. I can change that to 0 as well. I could remove the turn left command. And then what I can do is I can create sub-goal labels using the comments. So I can right click on my code like so. And add comment. So I can say, well, let's do it for this one. And I can type in the message, type in the correct number of iterations, for example. And I can put in another one, add comment and say, add in the missing turn left command. So students have got the main bulk of the code, and all I have to do is concentrate on filling in the gaps or fixing the code to make it work. And what you can do is over time you can fade these, so you can make them more difficult. So you start off with a pretty much completed solution with a few elements missing, and then you can start to delete more and more and take out more blocks and adding more labels to the point where basically you've just got a load of labels and the students create the code from scratch. So it's a great way to differentiate as well. Minecraft and MakeCode in particular is also suitable for supporting transition. So when I first started teaching computing, a lot of my students' previous experience was from using Scratch in primary school. Some had never even done any programming at all. And I found that it was a massive jump moving from using blocks and programming a Scratch cat or in a 2D visual environment to coding with text. So to support transition, Minecraft does this lovely thing. So I'm going to go back to my code. I'm going to open up my raining chickens code. And at any point, I can switch between blocks, JavaScript, and also Python as well, all in the same environment. So the environment stays the same, the interface stays the same, it's just the code that changes. And the other thing I can do is I can change these and it'll update each of the sections live. So if I were to change the number of chickens to 1,000, and then I go back to my blocks, it will change my blocks to 1,000. There we go. So I can switch between the two. So once I've started to master blocks, I can start to experiment in Python. But if I get stuck, I can always fall back to blocks again. The other nice thing is for those that have used blocks, you can also drag blocks of Python or JavaScript. So if I wanted to spawn a chicken, but I've forgotten what the code is for chicken, I can either type in, so I remember it's mobs dot, and it should bring up a menu. Let's just check mobs, or it could be spawn. There we go. I can drop that in like that. There's my code. So I can drag and drop blocks in the same way as I would drag and drop blocks in Scratch, but I can do it text of that again. So I can click on mobs, find my code to spawn a chicken, and I can just drag that and drop that in there like so. I can also type in the code. Let's try again, mobs dot, and it should give me a list of, oh, there we go. So it starts to give me a list of all the different functions I can choose. So I can spawn or near or entity. So I can then click on that. That's the one I want, spawn, and it'll fill in the code for me. Like so. And once I've mastered the code, I can tinker with it as well. So I've made it rain chickens. So I can also make it rain, let's say, for example, cats and dogs, although we haven't got dogs in Minecraft, we've got wolves. So we've got cats and we could have llamas. There's the cat. So make it rain cats and dogs. And again, I can click on Python to see what the code looks like in Python. And I can change the height in here, like so, because I'm starting to get more comfortable in using the text-based, and I can run that. And this time, when I type in the word chicken in the chat, it's raining cats and wolves. They're chasing the sheep. Okay. And just to show you what you can do with code, this is created using JavaScript, and this uses functions and a random generator. So each time the function runs, it picks a random number, and then that decides whether it's going to be a skyscraper made out of glass blocks or stone blocks, and also chooses whether it's have a nice environment-friendly glass roof or a stone or iron roof. Now, I'm not saying that your students will be able to create that in week 1, but it just shows you what you can create using code in Minecraft. Now, I mentioned at the start as well that you can also use Minecraft to explore Boolean logic and simple Boolean logic. So in Minecraft, we have an item called Redstone. Redstone is pairing Minecraft, and it has 2 states, on or off. So we can use this to teach binary and also create Boolean logic. So here are some example circuits, and you can again download this world for free. So just go to education.minecraft.net and you can download the world and the associated lesson resources. But here we have an input-output gate, a NOT gate, we've got an AND gate and NAND gate as well. And we can have the children create truth tables. So in this example, the output is a lamp. So here is a logic gate for AND gate. So we have 2 inputs, levers, and we have our output, which is our lamp. And the lamp will only ignite when both lever A and lever B are on. Now, you can have fun with this and change the output to a door. So it'll only open or close a door if it's the correct levers switched on, or you can have pistons and lots of other things, anything that can be triggered by Redstone. Again, you can download that world for free. Just go to education.minecraft.net and search for Boolean logic, and you'll be able to download the world and associated resources. So if you enjoyed that and found that useful and you want to find out more and want to start using Minecraft to teach computing or coding, there's a number of things you can do. So firstly, you can go to the official website, which is education.minecraft.net. Here you'll have getting started guides, but you'll also have tutorials, and you can search for lessons and resources, particularly around computing and coding. This is where you'll also find the Area of Code tutorials as well. If you use social media, and particularly if you use Twitter, you can reach out to us using our Twitter handle @PlayCraftLearn. And we've also got some more webinars coming up, which you can search for by going to aka.ms/MinecraftEDU UK activities. It's not case sensitive, but make sure you put the UK into Minecraft EDU UK activities. You can also become a Minecraft certified educator like myself. Just search using your preferred search engine for Minecraft Education Edition Teacher Academy. Sign up for free using your Office 365 account, and here you'll find tutorials, resources, guides and lessons which will introduce you to game-based learning theory, explore how you can use Minecraft across the whole curriculum, and also beginners to advanced tutorials where you can also learn how to use Redstone. We've also set up a free Minecraft UK community that you can join. Here you'll have access to educator resources, in particular curriculum mapping guides. So we've mapped at the moment the English curriculum for maths, English, humanities, so history, geography, citizenship, science, and also computing. The attainment targets to existing worlds on Minecraft. You can download this for free for Key Stage 2, Year 3, all the way to Year 6. We're also working on the Key Stage 3 guide at the moment as well. You'll also get access to news and updates for the latest build challenges and competitions. We have an awesome competition at the moment where a group of students can win an Xbox for themselves and also Experience Day for their students. And you can access this at aka.ms/MinecraftEDU UK community. Again, it's not case sensitive, but make sure you use the UK. So aka.ms/MinecraftEDU UK community. And you'll find these links also in this playlist as well. And finally, if you found this webinar interesting or useful, where next webinar is going to be on humanities. So how you can use Minecraft to explore history, geography, and citizenship. So I hope you can join us for that. If not, or if you have a colleague or friend that might be interested, please share the link. And you can sign up for that for free at aka.ms/minecraftedu/humanities. So thank you for joining us. I hope you really enjoyed that webinar and hope you found that useful. We appreciate you giving up your time and hope to see you again. So thank you and take care.